Hello, trig fans. Okay, today we're going to talk about double angle. And what I mean by double angle is basically, so this is double angle. What I mean by double angle is cosine of 2a. Very simple. Twice an angle. Alright, so let's derive this real quickly. Cosine of 2a is the same thing as saying cosine of a plus a. Which, if I know my sum formula for cosine, remember it's cosine A, cosine B minus sine A, sine B. Well, obviously we have A and A, so we just say it's equal to cosine of A minus opposite sign, sine of A, sine of A. And that's the same thing as saying cosine squared of A minus sine squared of A. So that's one of the formulas for cosine of 2a. Now, if you remember, one of our identities, we have sine squared of theta plus cosine squared of theta equals 1. And I can actually rewrite that, and I can solve for either sine squared of theta or cosine squared of theta. So if I solve for cosine squared of theta first and subtract sine squared of theta from both sides, I get cosine squared of theta is equal to 1 minus sine squared of theta. Those are some of the identities that you were asked to memorize too, so you should know that. Well, anyway, I can take this cosine of theta and I can substitute it into for that cosine of theta, and I would have 1 minus sine squared of a. That's cosine squared of a minus sine squared of a. So I just did a direct substitution of cosine into 1 minus sine of a. And then I simplify, and that's equal to 1 minus 2 sine squared of a. So that's another one of the identities just for cosine of 2a. Then of course I can solve, instead of solving for cosine squared, if I have sine squared of theta, that's 1 minus cosine squared of theta. So then into sine squared of theta I can substitute there, and I get cosine squared of a minus, and then sine squared of a is 1 minus cosine squared of a. And I distribute the negative, minus 1 plus cosine squared of a, and I simplify it finally as 2 cosine squared of a minus 1. That is also another one of the identities. So there are three separate identities for cosine of 2a. Do you have to memorize all three of them? Personally, I don't. What I do memorize is I know this one right here. I know the first one, and then I know I can substitute sine squared is equal to 1 minus cosine squared, or cosine squared equals 1 minus sine squared into that to simplify it. So it's good to know all three, but you really need to only know one of them and then be able to substitute in after that. Okay? Alright, so let's talk about sine of 2a. Okay, let's derive that. So that's sine of a plus a, and that's equal to sine of a cosine of a, and then same sign, plus cosine of a sine of a. And of course, sine a cosine a is the same thing as cosine a sine a, just flipped around. So I can actually write that as 2 sine a cosine a. And that is the identity for sine of 2a. And lastly, I can do tangent of 2a. That's, again, tangent of a plus a. And that is tangent of a plus tangent of a over 1 minus tangent of a tangent of a. Very easy to derive it. As long as you know tangent of a plus a, sine of A equals A and cosine of A equals A, it's very easy to derive these equations. So that's 2 tangent of A over 1 minus tangent squared of A. And that is your double angle formula for tangent. Okay, so let's use some of these identities. Basically what we're doing is we're trying to write a trig function. So we're writing a trig function as a single function or number. So for example, 1 minus 2 sine squared of 30 degrees. The key here, guys, is you need to always ask yourself, because we used A to derive it, and you always ask yourself, what is A? Well, you should recognize this formula right here is basically the double angle for cosine, because its cosine of 2A is 1 minus 2 sine squared of A. Okay, it's one of those three formulas. So once you recognize that, you're going to say to yourself, A is equal to 30 degrees. Because that was the form that we had. It was 1 minus 2 sine squared of A. So A is 30. So I literally substitute that into there, and I say, oh, okay, well, that means that's cosine of 2 times 30, which is cosine of 60 degrees, which is 1/2. That's the answer to that problem. Okay? Pretty mellow. All right, so let's try one. Now, obviously, that last problem you could have done real quickly. You could have just said sine squared of 30. You could figure out what that was. And that was, you could have figured out without converting it from 1 minus 2 sine squared of 30 to cosine of 2 times 30. But what happens if I have a problem like this? Cosine squared of 22.5 degrees minus sine squared of 22.5 degrees. Again, you should recognize this as a double angle for cosine. Cosine squared of A minus sine squared of A. Once you do that, you ask yourselves, what is A? A is 22.5. So this is a double angle. It's cosine of 2 times A, which is cosine of 45 degrees, which is root 2 over 2. Okay, so you couldn't have done it without double angle. You could not have done this problem because we don't know what cosine of 22.5 degrees is, but we do know cosine of 45. Okay, here's another example. 2 sine of 45, cosine of 45. Now again, you could do that. You could say 2 times sine of 45 is root 2 over 2. Cosine of 45 is root 2 over 2. And that would give you 2 times 2 is 4 over 4, which equals 1. Now you could do that. But let's actually convert it into our double angle for sine. Again, you're going to say, what is the value of A? Okay, A is 45 degrees. Well, that means that's sine of 2 times 45, double angle for sine. So it's sine of 90, which is just equal to 1. Okay, so that's another example. Okay, let's try another one here. Let's just do one in terms of theta. So we're not actually going to have an angle here. We have 2 sine of 10 theta cosine of 10 theta. Well, once again, you're going to recognize this is a sine of 2a, double angle for sine. And again, here's your value of a. So it's sine of 2 times a, or 2 times 10 theta, which is equal to the sine of 20 theta. That's your answer for that. Okay, let's try another one. 2 sine of 30 degrees cosine of 30 degrees. Once again, double angle. What is the value of a? A is 30 degrees. So that's the same thing as saying sine of 2 times 30, which is the sine of 60, which is root 3 over 2. Okay, so again, you could have done that without doing the double angle, but again, if I give you a problem like this, 2 cosine of 15 degrees, sine of 15 degrees. Notice that it's cosine first, then sine. That doesn't matter. Okay, so that's, again, double angle for sine. You can ask yourself, what is A? A is 15 degrees. We really can't solve this problem without double angle. So it's going to be sine of 2 times 15 degrees, which is sine of 30 degrees, which is 1/2. Okay, pretty easy. Let's try another one here. 10 minus 20 sine squared of 15 degrees. Well, this kind of looks like it kind of looks like cosine double angle, but it's not quite, because we need 1 minus sine squared of a. Well, what we can do is we can actually factor out a 10, and that would give us 1. Well, actually, we'll put the 10 on the outside. So it's 1 minus 2 sine squared of 15 degrees. Now, this part right here is cosine double angle. So it's 10 cosine. Again, our value of a is 15 degrees. So it's 2 times 15. That's equal to 10 times cosine of 30 degrees, which equals 10 times root 3 over 2, which is 5 root 3. A little more challenging one, but the same idea. If I had 1/6 minus 1/3 sine squared of 22.5 degrees. Brutal looking, it's brutal, but you can kind of tell that 1/6 is actually half of 1/3. So really what I'm doing here is I want to make this first number a 1. Okay, this is going to be a 1. Okay, I want to get rid of that 1/6. And basically the only way to do it is if I factor out a 1/6. So it's like dividing by, you're basically dividing by 1/6. I'm dividing this by 1/6. So if I write this out here, it's like 1/6 times 1 and minus 2 sine squared of 22.5 degrees. Okay, so now I definitely recognize that as a double angle for cosine. So that's equal to 1/6. My value of a is 22.5. And it's going to be 1/6 times cosine of 2 times 22.5. That's 1/6 times cosine of 45 degrees, which is equal to 1/6 times root 2 over 2, which equals to root 2 over 12. And that's the answer to that problem. Okay, so one more here with using tangent. And again, this one's pretty obvious. 2 tangent of 22.5 degrees over 1 minus tangent squared of 22.5 degrees. So you recognize this is 2 tangent of A over 1 minus tangent squared of A. And so again, you're going to say, well, A is 22.5 degrees. So that is just a double angle. So it's tangent of 2 times 22.5 degrees, which is the same thing as tangent of 45 degrees. And we all know tangent of 45 degrees is 1. That's your answer. Okay, so that's fine. That's actually using the double angle. Okay, so let's try a triangle problem. Basically, I'm going to ask you to find 3 trig functions of 2 theta of a double angle where sine of theta equals negative 7 over 9 and cosine of theta is less than 0. Now, I used to be nice and friendly, and I used to tell you a ratio for sine, cosine, or tangent, and then I also told you the quadrant. Well, now I'm not quite as friendly, okay? But it doesn't really matter. You really can get the information that you need. And the deal is that when you sketch your picture, because you have to sketch a picture. If you don't sketch a picture, you're not going to get it right. So it's a must. First of all, sine is negative in quadrants 3 and 4. So that's one thing that I know. And again, I'm not giving you the actual quadrant, but I'm telling you, hey, cosine is negative also. And cosine is negative in 2 quadrants. It's negative in quadrant 2 and 3. So the quadrant where it overlaps is quadrant 3. So I know I need to sketch my picture in quadrant 3. And then you just kind of label everything. Sine is y over r, so it's negative 7 and 9. And I use Pythagorean theorem, and I get negative 4 root 2. Okay, so that's pretty simple. So now what I'm going to do is I'm going to find sine of 2 theta. Well, what I do is I need to get, it's 2 sine of theta cosine of theta. So I already have, this is given, sine of theta is equal to negative 7 over 9. Well, cosine of theta, it's just x over r, so negative 4 root 2 over 9. And tangent of theta is the yax, so it's negative 7 over negative 4 root 2, which I'm not going to rationalize it yet, but it's 7 over 4 root 2. Well, now I have all the trig functions that I need to, well, at least to solve the first one here, sine of 2 theta. So it's 2, and it's literally a substitution just like we've done in the past. Sine of theta is negative 7 over 9. So it's negative 7 over 9. And cosine of theta literally is negative 4 root 2 over 9. So that's equal to, if I multiply all that out, I get positive 56 root 2 over 81. That is sine of 2 theta. Pretty simple. Next one is cosine of 2 theta. Now we have 3 formulas to use. We have cosine squared of theta minus sine squared of theta. We have 1 minus 2 sine squared of theta and 2 cosine squared of theta minus 1. So you have one of those 3. My recommendation is, you know this one already. This is given. So why not use something that's given? You'll get it right no matter what you do if you have all the right numbers. But let's say you made a mistake, you didn't do the Pythagorean theorem correctly, and you got, instead of negative 4 root 2, you got something different. If you use anything with cosine of 4 or cosine of theta, you'd get it wrong then, because you figured out things wrong. So in general, you always use, if you can, use something that's given. And if you have to, then you have to use something that you've calculated. So in this case here, I'm given sine, so I'm going to use 1 minus 2 sine squared of theta, because that's given. So that's equal to 1 minus 2, and sine of theta is negative 7 over 9 squared. So that's 1 minus 2 times 49 over 81, or 1 minus 98 over 81, or negative 17 over 81. So that is cosine difference. So I can use our formula that we created here for tangent, the one we derived, or so you guys know that's 2 tangent of A over 1 minus tangent squared of A. So let's actually use that. So we're going to do 2 different ways here. So tangent of 2A is equal to 2 times tangent of A, so 2 times 7 over 4 root 2 divided by 1 minus 7 over 4 root 2 squared. Okay, it's going to give us 14 . That's going to give us, that cancels with that, so it's 7 over 2 root 2, and that one's going to be 1 minus 49, and 4 root 2 squared is 16 times 2, so 32. Okay, that's looks a little nasty, but we're just gonna, well, first of all, let's combine the bottom here. It's a little math here. 7 over 2 root 2 divided by 1 minus 49 over 32 is going to be negative 17 over 32. So that's 7 over 2 root 2 times negative 32 over 17. And that cancels the 1 and negative 16. So negative 112 over 17 root 2. And our last step then is rationalize. It's a little evil nasty, right? And we get we can take a 2 out of there then, so it's actually negative 56 root 2 over 17. Whew, brutal. Okay, so that is tangent of 2A. Now I said there's another way to do it, and we already know that tangent of theta is sine over cosine, so tangent of 2A is sine of 2A over cosine of 2A. Can always use that nice identity. So let's actually do that. Sine of 2A is 56 root 2 over 81 divided by negative 17 over 81. Well, the beauty of this is we have the same denominator. So it's 56 root 2 over 81 divided by, or times the reciprocal. So negative 81 over 17. They cancel and we get negative 56 root 2 over 17. Wow, that was a ton faster. Okay, so that probably helps out a lot, just recognizing that identity. Now, if I just asked you for the tangent of 2A without asking you for anything else, you'd have to find sine and cosine and then divide it out, as opposed to if I asked for all three, you definitely are going to do it, and then you can just divide it out, and it's really easy. So it all depends. Sometimes you might use the identity. Sometimes you might use sine over cosine. Anyway, that's it for double angles, and have a good day. Goodbye.